Before starting this lesson, why don't you pause the video and try this warm-up question. So when you're making a sketch of a graph, just some things to keep in mind. You want to have a consistent scale along your axes. Now I haven't put any numbers on here because I'm just trying to be quick, but each tick would be an hour, okay? So for 2 hours, he's driving at a constant speed in one direction, so that would be this line, and he stops, so his distance is not changing. He's staying at the same distance for half of an hour. And then he's driving again at a constant speed, just faster. So he's going more distance in less time. So that would be a steeper line on the graph. And that brings us to this lesson. So we're talking about distance-time graphs. So what is a distance-time graph? Well, it's kind of like what you just did in the warm-up. You're graphing distance against time. You're finding the relationship between distance and time. Okay, here's my first example. So here I have D and T on each graph, and D is measured in meters, T is measured in seconds. So D represents distance, T represents time. If you recall from the last lesson, we had the independent variable on the x-axis and the dependent variable on the y-axis. Well, anytime you're dealing with time, time is independent of everything. Time just keeps moving. It doesn't matter what your distance is, time keeps moving on its own. So you never have to be confused if time is one of your variables. It will always be independent. It will always go on your x-axis. Okay, so my question is to explain each graph. So what I mean is you can just describe what this would be representing. So if we think about, like in the warm-up, he's driving his car. Well, here at the start, so when time is 0, he already is a certain distance away. So he's starting a certain distance away. He's driving farther away. His distance is increasing over time. Whereas over here, the car starts far away, but then he's traveling towards our reference point. In this one, he's traveling towards the reference point, but what's the difference between this graph and this graph? Well, in this one, he's traveling faster. He's going a greater distance in less time. Okay, this last graph, well, from start to finish, his distance is not changing. Which means what? Well, he's sitting still. He's not moving. So we're moving away, moving towards faster, and staying still. Okay, let's do some examples. So we're going to draw distance-time graphs. The first one, we're starting 4 meters away. Okay, let's pause there for a second and think about what would that look like on the graph. Well, if it's 4 meters away, his distance is going to be 4 meters at the start. So we would make a consistent scale on our distance axis, our y-axis, and we're starting 4 meters away. Okay, let's continue. And he's walking slowly back. Okay, so if he's walking back, his distance is going to get smaller. But he's going slowly, so it's not going to happen quickly. It's going to take more time. So you'll end up with a graph that looks something like this. Okay, let's switch gears a little bit. Now he's starting 1 meter away, walking quickly away at first, but then slowing down while still walking away. Okay, let's break that down. Starting 1 meter away. So here we are, make a consistent scale. We're starting 1 meter away, walking quickly away at first. Okay, so quickly, that's going to be a steep line. So something like that. But then he's slowing down while still walking away. Okay, so he's still walking away. His distance is going to increase more and more and more, but he's slowing down. So it's going to take more and more time. It's going to look something like this. He's going fast, but then he's slowing down. But his distance is still increasing. So it looks almost like a curve at that point. Okay, our last example for this lesson, we're going to describe Bob's trip. So Bob went for a walk, and we want to describe his trip in a few sentences. So here we have his distance from home and the time in minutes. Okay, so let's start at the beginning. Where is he starting? He's starting 200 meters from home. Okay, so Bob started 200 meters from home. Okay, now what happened? Well, let's look at this section of the graph. Is he walking away from home or towards home? Well, his distance is increasing. He's getting farther from home. Now, how long did it take? Well, he started at 0 time, 0 minutes. This section ended at 3 minutes. So it took him 3 minutes to walk 300 meters. So how fast was he going? Well, if he's going 300 meters in 3 minutes, 300 divided by 3 gives us a speed of 100 meters per minute. So I can update my description to include this. He walked at a constant speed of 10 meters per minute until he was 500 meters away from home. What happened next? Well, his distance is not changing, but the time is. So from 3 to 4.5 minutes approximately. So for the next minute and a half, he's not moving. He stood still for 1.5 minutes. The next part of his journey, well, he's starting out with a really steep line, but then it gets less and less steep as he travels. So what does that mean? Well, he's going fast at the beginning, and then he slows down. So we can say he ran towards home, but slowed down until he ended 20 meters from home. So just remember, on a distance time graph, a straight line means you're traveling at a constant speed, whereas a curve means you have a changing speed. In this case right here, he's slowing down because the line's getting less steep. If you have questions about that, please let me know. Otherwise, you can move on to the independent practice questions in the textbook. And again, with those, let me know if you have any issues or problems, and I'll do my best to help.